In this video today we're going to do coordinate proofs. We're going to prove that shapes are a parallelogram, rectangle, rhombus, or square by using slope and Pythagorean's theorem. So by the end of today you're going to be able to say I can determine the type of quadrilateral represented with coordinate points and justify it by using slope and Pythagorean's theorem. We're still on big idea 1 and we're doing AKSIOA 3B, and we're really focused on slope here today and distance, which we can do with Pythagorean's theorem. We can use midpoint formula as well to prove that something's a parallelogram. So first of all, this first slide says, what do you notice and what do you wonder? So I noticed that this first shape looks like it's a square, but I would have to prove that. Remember, we're doing proofs now, so we have to prove that it's a square. This one looks like it's some sort of parallelogram, which means it could also be a rhombus. And if it's a rhombus, it would have congruent sides, right? And then this one to me looks like it's a rectangle. And again, remember, the way we determine whether these two are square and rectangle, we can compare their diagonals, but today we're going to talk about side lengths, okay? Because on some assessments, you're going to have to say the side length was this, the slope was that, and so we're going to work on that today. So remember our properties again. Parallelograms, opposite sides are parallel and congruent. Opposite angles are congruent. Diagonals, consecutive angles are supplementary. Diagonals bisect each other. This means they have the same midpoint, okay? That's what that really means, is that they have the same midpoint. So we're going to write midpoint in the same, okay? And then when we're talking about these opposite sides are parallel, that's slope. Congruent is Pythagorean's theorem. Opposite angles are congruent. That we would have the measures and we would be able to determine that they were the same. Consecutive angles are supplementary. That means when we add them together they equal 180. So rhombus has all the properties of a parallelogram, and then all sides are congruent. That means they're equal, right? Diagonals are perpendicular, and that means what? They have negative reciprocal slopes, right? Remember that? And then again, bisects the angle. That just means they cut the angles into two equal parts. Then when we talk about the rectangle, it says all parallelogram properties and all right angles. Again, how do we determine that? That means they're perpendicular, and that means the slopes are negative reciprocals again. Okay, and then diagonals are congruent. That means they're equal. Okay. So then we get down here to a square. Basically, every property above that we've discussed applies to a square. So all sides are congruent. That means they're equal. All right angles, again, that means the sides are perpendicular. Diagonals are perpendicular. Okay, and then remember, both of these mean that they are negative reciprocal, reciprocal, slopes. Okay, that's what that's talking about. And then angles, and they bisect the angles. Okay. All right, now we're going to look at these two shapes. So it says, prove the following figure is a parallelogram. So if I want to prove that this is a parallelogram, then I have to prove that opposite sides are parallel and congruent, right? So we're just going to look at the slope of AB, okay? So we're going to go up 1, 2, 3, 4, 5. So we're going up 5 and over 1. So the slope of AB is equal to 5 over 1. And notice, same way down here, 1, 2, 3, 4, 5, up, 1 over, right? So that's also equal to D, or CD. So we've already concluded CD is also 5 over 1, right? Okay, now remember, we take our original numbers to find lengths. So now we're going to talk about the lengths. So now we're going to talk about the lengths of AB and CD. And because the two side lengths of our right triangle that we just created, we're going to use Pythagorean's theorem. Okay, so we're going to use our a squared plus b squared equals c squared, thinking that we want to solve for c, right? So it means we're going to take the square root of this and square root of that. So this side right here is c, right? So we're going to make this our a, and we're going to make this our b. Okay, so what we're going to do is we're going to do 5 squared plus 1 squared, take the square root of that, that's 25 plus 1, so that's the square root of 26, and that is the side length of AB is going to be equal to CD, which is going to be equal to the square root of 26. And again, the reason this is important is because some questions will ask you what the side lengths are. Okay, now we're going to work on BC and AD. Okay, so again, notice BC is going down, right? So we're going to count 1, actually let me do this in red, 1, 2, 3 down, right? So We got negative 3. And then we're going over 1, 2, 3, 4. Negative 3/4. Let's check the other side as well down here. 1, 2, 3 down. Negative 3. 1, 2, 3, 4 over. Okay, so what does that mean? So that means our slopes again of our opposite sides. Oh, by the way, I could have wrote up here and I didn't. AB is parallel to CD, right? Okay. So now we're talking about our slopes again of BC and AD. BC is equal to AD. Those slopes are because they were both equal to what? Negative 3/4. So that tells us again that BC is parallel to AD. Now, because again, those measures are the same, negative 3 and 4, we're going to take the square root. So we're going to say BC is going to be equal to AD, and we're going to take the square root of negative 3 squared plus 4 squared, and that is 9 plus 16, which is the square root of 25, which we know is 5. So that means BC is equal to AD is equal to 5. Okay? Now, because opposite sides are parallel and congruent, we can say this is a parallelogram, right? And it said, prove the following figure is a parallelogram, right? So let's mark these sides now. Now we said that these two sides were parallel. Those are those arrows, and congruent, right? And then the other pair of sides is also parallel. That's what those arrows mean, and congruent, or the same length, okay? So now let's look at, it says we're going to prove that this is a rhombus. Same thing. Okay, now what's the definition of a rhombus? It has what? 4 congruent sides, right? So we're just going to use the rise over run again. So everybody watch. So AB, I'm going to conclude, is going to be, let's check. 1, 2, 3, 4 up, 1 over. And this is 1, 2, 3, 4 up, 1 over. So AB is going to be parallel to CD, and their slopes were what? 4 up, 1 over, which means they're 4, right? Okay. Now let's look at BC. BC is 1 up, 1, 2, 3, 4 over. So this was 1 up, 4 over. And this one is 1 up, again, 1, 2, 3, 4 over. Okay. So again, what we could have said here too is that AB was equal to CD, again, because they had the same two numbers, right? So we're doing 4 squared plus 1 squared. So that was going to be 16 plus 1, so that's the square root of 17. Now, the slopes of our other pair of sides, we said BC is going to be parallel, right, to AD, because they had a slope of what? 1 over 4, right? Okay. Now, notice those are the same numbers we just did, 1 and 4, right? So obviously the square root of 1 squared plus the square root of 4 squared is still going to be the square root of 17, right? So now what can we say about all 4 sides? We can say AB is equal to BC is equal to CD is equal to DA. And that means it's a rhombus because it has 4 congruent sides, right? Okay. Now, this next one says match the shape below with their most accurate name. Now, we could do this with side lengths, but remember, we can also do this with diagonals. And diagonals are going to be the quickest way to prove that shapes are what they are, okay? So, I'm proposing that the first shape to me looks like a square, right? So, I'm going to say, is it a square? Question mark. If it is a square, then its diagonals are both perpendicular and congruent, okay? So that's what we're going to check. So we're going to check, let's go ahead and just check WY first. WY right there. So when we look at WY, it is 1 up. No, sorry. What am I doing? It's falling. Oh, never mind. 1 down. 1. So we're going from here. 1 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be 1 squared plus 9 squared. That's the length of it. The slope is 1 over 9, right? Okay. And it's negative 1 over 9 because we went 1 down, didn't we? Want negative 1 over 9. Okay. So that's going to be 1 squared plus 9 squared. That's going to be the square root of 82, right? Okay. So now, how do we determine if this is a square? We're going to determine if the other diagonal is congruent and perpendicular, okay? So we're going to look at xz. Now, we can tell this one rises from left to right, can't we? Sorry, my line's not very straight, but so once again, we're going up 1. Let me do this in a different color. 1, maybe if I can get it to put 1, 2, 3, 4, 5, 6, 7, 8, 9. So we went up 9 and over 1, right? So up 9 over 1, so that's 9 over 1. So hey, we can already see that the slopes are perpendicular, right? So WY is perpendicular to XZ. So that's one condition met. Now, did you notice that they're the same numbers as we just did a second ago? So here we go. Again, we're doing 9 squared plus 1 squared, right? So that's going to, again, be the square root of 82. So that also means WY is equal to XZ. So that means this is a square. So that's my C. So that one's done. Okay, let's look at the next one. So the next one to me looks like it's either parallelogram or a rhombus, okay? So if it's a parallelogram, well, actually, let's just see if it's a rhombus. Okay, so we're going to check the diagonals here first, and then we're going to see if they're perpendicular. Because if they're perpendicular, then it is a rhombus, right? So let's just check that first. So I'm going to check EG right here. EG. So this one is going down 1 over 1, 2, 3, 4, 5. So that's negative 1/5. So if this is perpendicular, the other one would be 5, right? Okay, so let's check it. So we're going up 1, 2, 3, 4, 5, 6, 7. 7 up, 1 over. So they definitely are not, 7 up, 1 over. They're definitely not perpendicular, right? Okay, so we know it's not a rhombus. So then what is the other thing that we would do here? We would check to see if they have the same midpoint, okay? So if we're checking midpoints, we're going to look at the midpoint of EG, okay? So the midpoint of EG, we're going to add our x's, negative 1 plus 4 divided by 2, and then we're going to add our y's, 5 plus 4 divided by 2, okay? So that's going to be 3 over 2 and comma 9 over 2, right? Okay, that's going to be our midpoint of EG. So now we're going to check the midpoint of FH. Okay, so here again, we're going to go 2 plus 1 divided by 2. And we're going to do 8 plus 1 divided by 2. So what do we get here? Didn't we get 3 over 2? Well, that one checks out, right? And didn't we also get comma 9 over 2? Yep, the other one checks out as well. So this one is a what? A parallelogram, right? Okay. We saw that it was not a rhombus because the diagonals were not perpendicular, okay? So it was a parallelogram because the midpoints were the same. Now, let's go on to the third one, and we're going to compare the diagonals here because I propose that this one is a rectangle, okay? And if it is a rectangle, then the diagonals are going to be the same length, right? Well, that line didn't draw very straight, but that's okay. You guys get the drift. Now, notice that this also is by 2's. So as we're counting, we're going to count half spaces. So we're going to go 1, 2, 3. 1, 2, 3 down. No, I got one more. 4. Okay, so that's negative 4, and we're going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we went 12 over. So this is going to be negative 4 squared plus 12 squared, and we're going to take the square root of that, right? So that's going to be 16 plus 144, and I'm pretty sure that's the square root of 160. Okay, now we're going to do the other one and see if it's the same length, okay? And I'm going to keep saying this, the more you do this, the better you get at it, okay? So it's just one of those things that the more you practice, the better you get. So here we go again. Remember, these are by 2's, so this one is falling from left to right, so we're just going to go, yeah, they were both falling from left to right, aren't they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that was 12 down, so that was a negative 12. So we're doing our negative 12 squared. Remember, anytime you square any number, whether positive or negative, it becomes positive, right? And then we're going over 1, 2, 3, 4. So there's our 4 again. So we know that that's going to be the square root of 160 because they were the same two numbers. So if the diagonals are congruent, we know this is a rectangle, right? Okay, so that was B. Got it? All right. So it says prove that the given figures are rhombus, explain why or why not. So here again, you could prove that all four sides are congruent. There's a quick way to do that. Or you can just prove that the diagonals are perpendicular. Okay, so I don't care which way you do it, but I would propose that the diagonals is the quickest way. I'm going to show you how to do both. So this is 1, 2, 3, 4, 5, 6, 7 up, 1, 2 over, right? We're just going to go around the shape. This one's 1, 2, 3, 4, 5, 6, 7. And what? 1, 2, 3 down. Okay? So notice that this was 7 and this was 3. Keep going. 1, 2, 3, 4, 5, 6, 7. 1, 2, right? 7 and 2. And 1, 2, 3, 4, 5, 6, 7, and 3. Okay? 1, 2, 3. So is this going to be a rhombus? No. Why? Because the sides are not going to be congruent because they're not the same numbers. But I could have also done it like this, like we've been talking about. We could have just done our diagonals and seen if they have negative reciprocal slopes. Because if they do, if the diagonals are perpendicular, wow, it's not going to draw that line, y'all. Doesn't like me. We're going to compare these two diagonals and see if they are perpendicular. And if they are, then we know it's a rhombus. But if they're not, we know it's not. Okay? So let's just look at TR first. So we're going up 1, 2, 3, 4. So that's 4 and over 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 4 and over 9. So that would mean the slope of the other one would have to be negative 9/4, right? So we're going to see if it is. So in this we're going to count down. And it is negative. We know that. We can see it's falling. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5. 10 over 5, and that was a negative 10 over 5, right? So that's going to be equal to negative 2. So those are not negative reciprocal slopes, are they? Okay, close, but no cigar. So that means this is not, it is not a rhombus. And you could say for either reason. You could say because sides, all four sides are not equal, right? Or you could say the diagonals are not perpendicular. So in this next problem, example 3, it says given the coordinates m and o, if we want to create a figure MNOP into a rhombus, then what should the coordinate pair be for P? So what we're going to do is plot M, N, and O, and then we're going to see how we can use the slope to find point P. So let's go ahead and plot M at 1, 2. That's M. N at 4, 5. O is at 7, 2. Now, let's talk about the shape. There's M to N. There's N to O. So where would you predict P to be? I would say, and I think you should always do this, I think you should make a prediction where you think P is going to be. So I think P is going to be down here in quadrant 4. That's what I think, okay, based on what I can see. So we're going to use the slope from N to M, and notice I'm going from the top to the bottom. So I'm going to go 1, 2, 3 down. So that was 3 down. And 1, 2, 3 to the left. So we're going to look at the slope from N to M, N to M. And so we went 3 down and 3 left. So that's what we're going to do from O. We're going to count 1, 2, 3 down. And we're going to count over 1, 2, 3 to the left. So this is where I think P is, okay? So again, we're going to go from we're going to go from O to P. That's what we're doing. Now we're going to check it by looking at the other slope, okay? So now we're going to look from N to O. So we're going to look at the slope from N to O. So we're going to count down 1, 2, 3. So we went 3 down again, 3 down, and 1, 2, 3 right. Okay, so we went 3 right. So that's what we're going to do now from M to P. So from M to what we think P is, right? Let me try that again. So we're going to go from M to P. So we're going to go down 1, 2, 3, and over 1, 2, 3. Look at that. We got to the same point, didn't we? So because of that, we're going to say the point P is negative 1 comma 4. Okay? And we're going to draw our shape. And this, it said in the problem that this is a square. So notice that all four sides are the same because we had 3, 3, 3, 3, 3, 3, 3, 3. And you could even check the slopes, right? Because negative 3 over 3 is a negative 1, and 3 over 3 is a positive 1. All right, let's do this next one. Go ahead and pause the video here. Do this one. Come back to me when you're done. So here's A at negative 4, 2. Then we got 4, 0. There's our B. And then we've got C at 5, 4. Right there, C. So where would you predict D is going to be? I would say quadrant 2, which is this one right here. Remember, this 1, 2, 3, and 4, right? Okay, so I would predict that it's going to be in quadrant 2. Okay, so once again, we're going to draw these lines. Do the best I can to draw a freehand straight line. Okay, so once again, we're gonna go from B. We're always going to go from where the two sides come together. Okay, that's a key. So what I want you guys to do is just look at from B to A. So from B to A. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. 8 left, right? Isn't that what we did? 8 left. And then we're going up 1, 2, right? So up 2. So now what we're going to do from C is the same thing. So from C, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And then we said 2 up, right? So that's where we think D is. From C to D, same thing, okay? So let's double check this again. Now we're going to go from B to C. So we're going to go from B to C. So this time we're going up 1, 2, 3, 4. So 4 up and 1 right. So that's what we're going to do now from A to, again, what we think D is. So we're going to go up 1, 2, 3, 4, and 1 right. Look at that, same D. Y'all see that? Okay, so D is going to be at negative 3, 6. Does everybody see that? Okay, so again, we're going to draw the other two sides of our shape here. Sure enough, looks like a rectangle, doesn't it? Okay. All right, I want you guys to do the next one. Come back to me when you're done. So on this one, we got 0, 0 at Q. And then we got R at 3, 1. And then we got S at 1, 2. So Q to R, R to S. So if you go from R to Q, what did you do? Went 1 down, 1, 2, 3 left. So right, 1 down, 3 left. So from S to where we think T is, we're going to go 1 down, 1, 2, 3 left. This is where I think T is, right? So again, we're looking from S to T, same move, okay? So now let's look at from R to S. From R to S. Okay, so what are we doing here? 1 up, 1, 2 over. So 1 up, 2 left. So from Q, 1 up, 1, 2 left. See it? So notice again, we got the same T. So T is going to be at negative 2, comma 1. And I'm going to draw the other two sides of my shape. And This one looks like it's parallelogram, right? I didn't draw a very straight line, but y'all get it. Any questions? So my answer was, no, was it C? It was -2, -1, right? I almost circled the wrong one. So this was D. All right, so this next one says, prove that the triangles with the vertices A, B, and C is a right triangle. Determine which pair of sides are perpendicular. At what point is the right angle? So we're going to then plot these points again. 7, 2, right there. There's my A. My B is at 3, 3, right there. And my C is at 4, 7, up there. Okay, so we're going to go ahead and draw these lines. Okay, so what I want you guys to do first is I want you to predict, or let me just ask you this question. Where do you think the right angle is? So where do you think the right angle is? This is the question you should be asking yourself first, because that's going to help you proceed. So I would answer this question at B. Because can't you tell this is an acute angle and that's an acute angle, right? So we're predicting that it's at B. So that means we've got to compare the two sides that come in together at B. So we want to look at the slope of BC, and we want to look at the slope of BA. If these two slopes are negative reciprocals of each other, then we know there's a right angle at B, right? Okay, so let's look at BC. We going up one. Oh, let me do it in red. 1, 2, 3, 4. So we went up 4 and we went over 1, right? So up 4 over 1. So this is the slope of 4 over 1, which is 4, right? Now look at BA. We know that BA is falling from left to right. Can you guys see that right there? BA. So we're going down 1. So that was -1 and over 1, 2, 3, 4. So that's down 1 over 4. So that's going to be down 1 over 4. What do you notice about these two slopes right here? They're negative reciprocals of each other, right? So we can say that BC is perpendicular to BA, and where's the right angle at? I can't write today, sorry. The right angle is at B, isn't it right there? Isn't the right angle right there? Okay. All right, so go ahead and plot the points on this next one, and let's see if we can figure out where the right angle is again. Pause the video, come back to me when you're done. So we got 1, 4 right there, that's my A. Then we have 4, 3 right there, that's my B. Then we have 3, 0 right there, that's my C. So once again, we're going to draw. And again, my prediction would be B. Can you guys see that? I think the right angle is going to be at B, but we're going to prove that, right? So what are we going to do? We're going to compare AB slope to, to BC slope, right? So let's go ahead and do AB. So we're going down 1 over 1, 2, 3. Down 1 over 3, right? Down 1 over 3. So this is -1/3. So what should the slope of BC be if indeed there's a right angle at B? It should be +3, right? So again, I'm going to go from C to here to B. So I'm going up 1, 2, 3, and I'm going over 1. So that was up 3 over 1. So that's 3 over 1. That's equal to 3. Again, what do you notice about these two slopes? They are negative reciprocals of each other, right? So we can say AB is perpendicular to BC. So the right angle, again, is where? At angle B, right there, right? All right, do the next one. Pause the video, come back to me when you're done. So this one's -3, 2, right there. That's A. B is at 5, 0, right there. And C is at 2, 5, right there. So we are going to check this one. Now, where would you guess this time? Where's your guess? I would guess that the right angle is at C. I would. Okay. So this time we're going to look at what? AC and BC. Can y'all see that? Okay. So if we're looking at AC, we're going up 1, 2, 3. Y'all see that 3? And we're going over 1, 2, 3, 4, 5. So that slope is 3 over 5. And so what about CB? You can tell, BC, you can tell it's falling, right? So we're going to go down 1, 2, 3, 4, 5. Right, that was negative 5. So that's negative 5 over 1, 2, 3. Wow, I went down a little bit, but you guys saw what I was supposed to do. Negative 5 over 3. And can you tell those are, again, yes, hopefully you can see that very clearly, right? These are negative reciprocals of each other, so we can say AC is perpendicular to BC. Which point is repeated? That's one of your keys, right? So our right angle is where? C this time, isn't it? So my right angle goes right there, okay?